Okay, so this is Principle of Mathematical Induction. So again, Principle of Mathematical Induction is a way of proving something na it is true for all n element in natural numbers. Okay, so we have two parts or four steps in Principle of Mathematical Induction. The first step is to let the statement be p sub n. The second step is to verify if p sub 1 is true or if n equals 1 is true. The third step is you assume that it is true for n equals k, and you prove that it is true for n equals k plus 1. Or in short, you assume p sub k and then we show p sub k plus 1. The last step is for the conclusion. So, yun lang yung steps ng Principle of Mathematical Induction. So, for example, okay, so you are to prove that n plus 1 squared is greater than or equal to 2 times n plus 1 for all n in the set of natural numbers. Okay, so our first step is to let this inequality by p sub n. So let p sub n be the statement n plus 1 squared is less than or is greater than or equal to 2 times n plus 1. So the second step, or the first part of the proof, is to verify if n equals 1. So when n equals 1, yung n plus 1 squared, this is equal to 1 plus 1 squared, which is equal to 2 squared, which is 4. While yung 2 times n plus 1 ay magiging 2 times 1 plus 1 equals 2 times 2, which is also equal to 4. So therefore, when n equals 1, okay, so note that 4 is greater than or equal to 4. So this means that p sub 1 is true. So after mo ma-verify na true yung p sub 1, you assume that p sub k is true. So assume that p sub k is true. So when you say p sub k is true, you just substitute n by k. So meaning k plus 1, given na yung k plus 1 is greater than or equal to 2 times k plus 1. So ano yung gusto natin i-prove? You want to prove that p sub k plus 1 is true. So yung i-show natin ay p sub k plus 1 is also true. So ano yung p sub k plus 1? Yung p sub k plus 1 is when n is equal to k plus 1. Ito, when n equals k, ito, you want to prove that totoo din siya when n equals k plus 1. Okay, so p sub k plus 1, ito yung statement when n equals k plus 1. So we have k plus 1 squared is also greater than or equal to 2 times k plus 1 plus 1. So ito yung i-show natin. Okay, so or if we simplify, k plus 2 squared is greater than or equal to 2 times k plus 2. Okay, so ito yung gusto nating i-prove. Using this assumption, k plus 1 squared is greater than or equal to 2 times k plus 1. Okay, so mag-start tayo sa k plus 2 squared. So we have or dito lang sa k plus 1 squared. So we have k plus 1 squared. So this is equal to, using the square of a binomial where the first term is k plus 1 and the second term is 1. So we have k plus 1 squared plus 2 times k plus 1 times 1 plus 1 squared. Okay? So square the first term plus twice the product of the first and the second term plus the square of the second term. Okay, so note that from this assumption k plus 1 squared is greater than or equal to 2 times k plus 1, so pwede natin palitan yung k plus 1 squared by 2 times k plus 1, pero hindi na siya equal, pero greater than or equal to. So we have 2 times k plus 1 plus 2 times k plus 1 plus 1. Okay, so itong k plus 1 squared, pinalitan ko lang ng 2 times k plus 1, and then magiging less than or magiging greater than or equal na siya. And also, note that k plus 1, and also this greater than or equal to 2 times k plus 1 plus 2 times k plus 1. So, mas malaki itong nasa taas kumpara na sa baba kasi once you subtract by 1, liliit yung expression. Okay, so, and also, ang k dito is from the set of natural numbers. So, meaning, yung k mo is mas malaki pa sa 0. So, if you replace this k by 0, magiging greater than pa rin ito. So we have 2 times k plus 1 plus 2 times 0 plus 1, or we have 2 times 1. So yung k plus 1 is always greater than or equal to 1. So when you factor out 2, so this is equal to 2 times k plus 1 plus 1. So this means that k plus 1 plus 1 squared, this is greater than or equal to 2 times k plus 1 plus 1. So this is actually our p sub k plus 1. Ito siya. So that means that p sub k plus 1 is also true. Therefore, the last step is for conclusion. So therefore, n plus 1 squared is greater than or equal to 2 times n plus 1 for all n in the set of natural number by principle of mathematical induction.